Okay, what we're doing today, 11.4, we're multiplying and dividing rational expressions. Today we're going to learn about multiplying rational expressions, and we're going to divide rational expressions, or actually multiply by the reciprocal. We're really not going to divide. So what we're looking at here is we're just looking at multiplication, basically. So, erase the previous stuff. All right, so I have r squared x over 9t cubed times 3t to the fourth divided by r. Okay, so we're looking at multiplying. Since everything's multiplication, it's just straight across. So you don't do a cross multiply or anything like that. We're just looking straight across. But I can look ahead of time and kind of go, wait a second, can I subtract things? So I know I'm going to multiply the top and the bottom. I can look and say, well, wait a second, I have r squared and r. Well, let's simplify that right away. That's going to simplify down to r's. I'm done with the r's. I have an x, no other x's. So there's left with an x. I have a 3 and I have a 9. Well, that reduces. So the 3's gone out of there. That's going to reduce down to a 3. So over 3. T squared, or t cubed, and t to the fourth. So I subtract the powers. So I have a t. So rewriting this so it looks nice, I'm going to have rxt divided by 3. So I'm really just slide across the top, slide across the bottom. We could say that I have r squared x with the 3 t to the fourth over 9t to the third r. So I simplify, just multiply this, and then I start doing that cancellation. I can only do that because it's a multiplication. If it's addition, I can't do that. Remember, addition of fractions, I have to have common denominator. I have to go that way. Good thing we don't have to do that here. So I have that, and it will simplify into this. There's my 3, r squared r. There's my r, x, t to the fourth, t to the third, left with my t. So there is my final answer on that one. They have another one. Next example is a little more complicated because they have a plus in there. Man, they just got to go rowing it and put an addition and subtraction signs in there. A plus 4 over a squared times a over a squared plus 2a minus 8. Okay, so we have this. So I look at this and I say, well, I'm going to factor this. So I'm going to factor this one right here. A plus 4 over a squared times a over 2 sets parentheses. Tells me the signs are opposite. Tells me the bigger one's positive. A and an A minus plus. Two numbers multiply together to give me 8, and they have a difference of 2. And the bigger one is positive, so 4 and 2. Woohoo! I see this group and this group, because this is an entire group right here. That's the biggest catch here. This is an entire group. So it's a plus 4 times a. So it's a group here. And I have a group there. So I cancel those. I have a squared, which is by itself, times a. So that cancel into that. So I have 1 over a times a minus 2. We do not want to distribute this through. This would be a squared minus 2a. We don't want to distribute through. We just want to leave it right here in this form. Because then if they say, hey, what are our zeros? 0 here, and there's a 0 that's produced here. Okay, so 0 here and 2. So a equals 0 and 2 would be my final zeros here. So that's why I don't want to distribute through. So if it's distributed through, then I got to factor it right back out. So leaving it like this is the easiest way to manipulate this and use this to what we want. Okay, that should be pretty good. Okay. I know it's a pretty confusing topic though. This is another one that's on the ACT. They like putting stuff like this on the ACT. You want to get your good scores, good scholarships. This is the ones you want to focus on. All right. Example number 2. Anne won the 2007 World Racing Championship race in her category, and she finished the 88-kilometer course in 51.23 minutes. What is her average speed in miles per hour? Okay, so now we can go kilometers per minute by just doing 88 divided by 51.23. This one here, one of the few times that you'll actually see me have units on there. They give us a little bit of information saying 1 kilometer is 0.62 miles. Well, I need them to cancel. So for the units to cancel, I got 1 kilometer down here, and I have 0.62 miles up there. And I do what we call railroad tracks. So as soon as I have one conversion, I put another cross. So I just say, wait a second, think about this. That's kind of what my railroad tracks do. And then I have minutes, and I need that to go to hours. So I know that 60 minutes is 1 hour. And I need them to be crossed, because then this unit and that unit cancel. This unit and that unit cancel. So I look across and say, what are my units in? Miles per hour. Hey, that's the units I want to be in. So what I do is I multiply the top. So I go 88 times 0.62 times 60. And I take that divided by 51.23. I then cheat and look at the book and say I have 63.9. Yep. Miles per hour. So that's the units I'm left with. That's why I put those on opposite. So they have to be opposite sides. So units will cancel the same way as variables, because I can have x times 1 over x. So they cancel, and so it equals 1. So if I do it the same way, they cancel 1. And so that's just the way you look at it, and you think about the units, multiply the top, divide by the bottoms, and you're done. This comes up a lot in science, using this cancellation, physics, just great different things right there. You just unit cancellation is where you're looking at that. All right. Next topic. Next thing they're going to cover. They want to do division. Well, I don't really like doing division. I can't divide as well as I can multiply. So they have 4 divided by 15n cubed divided. I just hate that sign. That's why. 12 divided by 25n. So we don't like using that sign. So what we want to do is we want to reciprocate this and multiply. Reciprocate just is a fancy way to say flip it. So I'm going to flip it over. So I'm going to have 4 divided by 15n cubed times 25n divided by 12. So division, reciprocate, and multiply. So I reciprocate this. So I have this, and I can simplify that. Hey, that looks a lot better to me. Okay, I see a 5 here. If I cancel with this, and a 3, 4, and a 3. 2 3s to go together doesn't do anything to do with the 5. So I'm going to be left with a 5 over 9. I have an n here and an n cubed here. So it's going to be n minus 3. So I'm going to have n to the negative 2. N to the negative second. We got to remember that old rule is going to be 1 over n squared. That's the same thing. So n squared. So 5 over n, or 5 over 9n squared. Reciprocate and multiply. Reciprocate and multiply. That is the biggest thing. Okay, next one that we have. They're trying to throw a curveball at us. And we have 2x plus 6 divided by x squared. Divided by, and we're just going to reciprocate and multiply right away. So it's divided by x plus 3. Well, x plus 3, that's really x plus 3 over 1. So I'm going to go times 1 over x plus 3. Okay, remember these are groups, so be careful. I have that plus, that's a plus group there. That's a group here, so I can't just cancel out stuff. I can't just multiply stuff out. Look at this, I have x plus 3. Ooh, I can factor out a 2. So if I go that, I have x plus 3 there. So I have x plus 3 times that 2. Instead of murdering that. X plus 3, those will cancel. So I have 2 over x squared. Once I'm all done, because that and that will cancel. So I'm left with a 2, because 2 times 1 is 2. And I have x squared, And that cancels out. That really reduces down to a 1, so I have 1 over 1 there. So x squared. Even though it cancels, don't put them as zeros. They are not zeros. They're 1s. Okay? So I can manipulate this into being x over x, being x plus 1 over x plus 1. Okay, we can change all that. All right? So all I'm doing is I'm just doing a well-chosen 1. But those are groups. And if I cancel that back down, these cancel, this is still 1 over 1. It's not 0 over 0 because we cannot divide by 0. They have another example. Example B. Example 4b, a minus 2 divided by 4a plus 4. I'm going to simplify that right away, right out of the gate. Divided by, which we know reciprocate and multiply, a plus 1 divided by a plus 5. And I reciprocated and multiplied. Looking at it, oh, there it is. That's the cancellation. There's nothing else I can really cancel. So a minus 2 over 4 times the group of a plus 5. Make sure you have parentheses in there. So otherwise, this is 4a plus 5, and that's not right. And once again, we don't want to distribute through and have 4a plus 20. We want to leave it right there. That's our simplification, is to right there. And that's our final answer. Cannot cancel the a's because it's a group here and a group there. So that will not work. Can't divide that. So I am done. Don't try to go any further. All right, example number 5. I have y minus 3 over y squared plus, or y squared minus 10y plus 16. And it says divided, but we're going to multiply by the reciprocal. So y minus 8 is going to be on top, and y squared minus 9 is going to be on bottom. So I'm looking at this going, oh man, this is already done, this is done. The top is pretty good. The bottom is where I'm having problems. So I'm going to go y minus 3 over 2 sets of parentheses. This tells me the signs are the same. It tells me they're both negative. Y and a y. 2 numbers multiply together to give me 16, and they add together to give me 10. Ooh, 8 and 2. Remember, it's minus times y minus 8 over, ooh, they tried to trick me. Still 2 sets of parentheses. They're both going to be negative. Oh, one's going to be negative, one's going to be positive. Because that middle term needs to drop out. Y times y is y squared. Y times 3 is 3y. Y times negative 3 is negative 3y. Middle term drops. Negative 3 times 3 is 9. Negative. Boom, got it. Okay, so cancel, cancel. Cancel, cancel. So I'm left with 1 over y minus 2 times y plus 3. So there is my final answer right there. Simplified. Do not FOIL this thing out. Leave it as this, because they're going to say, hey, we're divided by 0. Where are they at? Where's our vertical isotopes? Those are the things that they're going to be looking for. So that's why we don't want to distribute them through, because then first step we're going to have to do is factor them back out. Okay, so simplified to that point right there. Okay, if you have any questions, comments, concerns, let me know. Shoot me an email.